Hello, and welcome to our first session on structural equation modeling using Amos. Coming to what is structural equation modeling. Structural equation modeling is a multivariate data analysis technique which helps you find relationship between latent variables. So even before understanding what is structural equation modeling, it's imperative that we understand what's a latent variable. Let's look an example at a variable which is say height. Height is measured in centimeters or inches and it is observable. So in that sense, it is not a latent variable, but it's an observed variable. A latent variable is more of an unobserved variable. An example of a latent variable can be attitude, intelligence, which is not clearly visible. I mean, it is something of an imaginary construct which can be construed by certain observed questions. So, to give you an example, usefulness. So there is a technological construct called as perceived usefulness. Uh, I administer certain questions to a respondent. I may ask question, does it help you do your work better? So the respondent may answer that in a Likert scale of 1 to 5. So I would administer 3 to 4 questions to the same respondent and measure what is, say, perceived usefulness. So similarly, there are many latent variables or constructs in social sciences. So structural equation modeling is a statistical technique which helps you find the fit between the model and the data, as well as confirming the relationship. So are you looking at a causal relationship? Are you looking at an independent dependent relationship? So in essence, it is an upgrade on the regression and factor analysis. Now, why are these two components so important? When I speak about factor analysis or confirmatory factor analysis, as I mentioned, the 4 questions that you give to your respondents to measure, say, attitude, how well do they load on attitude? So first of all, we would look at the measurement model. And secondly, once we identify that the model fits well to the data that you have collected, we can go ahead for structural model or hypothesis testing. There are various software available in terms of using structural equation modeling. So there are softwares like Literal, Amos, M plus. There are fine differences between this software. So maybe going ahead, I will explain which software is more suitable for what type of test. Now, coming to the importance or the benefits of using structural equation modeling, can be that you can work very well with latent variables or constructs. You can work with variables which are or research models which are specifically very complex. I have an example in the next slide where this is a research model or a conceptual model that I borrowed from one of my papers. If I can annotate, I have a technological construct called as perceived usefulness, which is nothing but the utility that you derive from using a technology. Another construct, perceived ease of use or the easiness of using that technology. Similarly, I would have multiple constructs like social influence, facilitating conditions. All of these are unobserved or latent variables. I have certain items or questions which I administer to the respondents and measure it on a Likert scale of anchored on a scale of 1 to 5 or say 1 to 7. Now, why have I put up this particular model here? If you look, I have latent variables of the first order, and these load on a latent variable which is of a higher order. So basically, these 6 first order constructs load on the second order constructs. Now, if I have to analyze such a complex set of relationship in regression or correlation, it would be very cumbersome, where I might have to look at individual relationships. And the biggest drawback of regression would be that I might sometimes not be able to account for measurement error. So when I look at a next model, I will just explain what's an measurement model. Okay, coming back to SEM, there are certain inherent limitations of SEM. Uh, the most obvious one would be that the model that I have derived is derived from the literature or from research that has been previously conducted. But a limitation of SEM might be that you might come up with a model which may be not grounded in research, and yet it can be tested, and the inferences drawn out of it might be spurious. So there is no restriction in SEM that you cannot mix and match constructs, but this can also be a limitation. And the second drawback of SEM might be that the size of the sample needs to be large enough to get reliable and valid results. Now, let's look at what is the theory behind structural equation modeling. If you are aware, if you take two variables and if you find the correlation between the two, it would be on the basis of covariance. A covariance is nothing but the formula that I have put up here. So I have variable x and variable y. So I take the mean of variable x and the mean of variable y. I take all the observations x1, x2, x3 and subtract it from the mean of x, and the product of this by the product of the difference in the observation of y from its mean, the product divided by the number of sample. So in this case, I am looking at a sample where n is the number of sample minus 1. So this would be for the sample. In case you are working with a population, then it would be divided by n. A simple example would be on the right hand side on the graph. If you see the covariance between x and y, it's positively increasing in a linear fashion. As x increases, so does y increase in the same direction. This could be an example of a positive covariance, and the second one would be an example of a negative covariance. So in essence, what Amos does, it calculates the covariance matrix for all the variables available. To give you an example, let's look at a So this is a very simple conceptual map where I have taken three individual constructs, one being perceived usefulness, which I've denoted as PU, perceived ease of use, and the behavioral intention to buy or adopt a particular technology. So I want to test this using structural equation modeling. So in this particular scenario, what I would be doing is, first I would make a research questionnaire. It would be an online survey where I would have 3 to 4 items or questions measuring perceived usefulness on a Likert scale. Similarly, there would be questions on ease of use and behavioral intention. So simple questions like, are you willing to adopt this particular technology? This technology helps me do my job better. So accordingly, these questions would be measured. Now, how does structural equation modeling help? So if I take the same set of constructs, I would be able to come up with a covariance matrix. So if you look at this particular covariance matrix, I have all my variables which are arranged in a matrix, where on the diagonals, I have the variance calculated for the each individual construct. So if I'm calculating variance for perceived usefulness, it could be the square of the difference of the observations minus the mean. So if I'm doing it this, it would be the variance. So those would come in the diagonals. And the covariance formula which I have mentioned here, xi minus x bar, yi minus y bar upon n minus n. This would be the covariance between PU and PEOU, which is denoted here. Similarly, I would have for my other two variables. So in essence, what SEM does is it calculates the covariance matrix. So there are two steps. Just a minute. Okay. So the moment you upload a data on your Amos software, it will calculate or it would calculate the observed sample covariance from the raw data. So if you have multiple variables, it will calculate. And then once you draw a particular relationship that we have drawn in our case, it will calculate the estimated covariance matrix. It will compare the estimated covariance matrix with the observed covariance matrix. And in case it is within the sampling variation, it is nothing but the estimate between the samples variability. We can denote if it is a good model. What in essence it means is that the model that you have created, how well does it fit the data? So that could be the first step, which is called as the measurement model. And once you find a good fit between the model and the data, you can go ahead with your hypothesis testing. So let's look at an example of a construct. So in this case, I have my construct perceived usefulness. It is measured with four items: perceived usefulness 1, 2, 3, 4, which are observed items which I stated to the respondent. And against that, I collect the data and I upload it in Amos. So in my next tutorial, I will actually show you how you would be able to draw the conceptual model and upload the data. Against this, you see these particular terms which are called as your measurement error. So if you are aware, any specific questionnaire or item that you measure will have an inherent measurement error, which is inevitable. So structural equation modeling helps you capture and account for measurement error. Therefore, whenever you go ahead for the structural or the relationship testing, we are able to account for that error, and the results that we receive from this are valid and reliable. So I hope you have understood what is structural equation modeling. So let me recap. Structural equation modeling is nothing but a multivariate data analysis technique which helps you do a factor analysis or finding the fit between the data and the model. And then finally, a structural model or a path analysis where you would check your hypothesis or the relationship between a dependent variable and an independent variable. We also understood what is a latent variable or a construct. So in our next video, we would be looking at what is a confirmatory factor analysis or measurement model. Thank you.